Okay, hello everyone. My name is Nathan, and today this workshop we are going to be talking about CAD in robotics, and it's being led by my robotics team, FTC 11138 Robo Eclipse. Shimon, Abigail, do you want to introduce yourselves?
Sure, I'm Shimon. I'm a sophomore at Interlake High School, and I'm currently a hardware member on Robo Eclipse.
Hi, my name is Abigail. I'll be going into 8th grade at International Community School, and I'm going to be doing outreach this coming season.
Okay, so for a general overview of what we're going to cover today, we're going to start off with an introduction to what CAD is and its applications. Then we'll talk about the first program introduction. We'll go over a season overview, game layout, some technical resources, and ended up with Q&A. So starting off with Intro to CAD, you might be wondering what CAD is and what it stands for. CAD is computer-aided design, which means it's a type of program where you can use and create digital models. This can be either 2D, 3D, and you can use it to design a lot of commercial products. So as you can see on the right side of our screen, on the bottom, you can create 2D sketches, and they're essentially, you can use them as blueprints to kind of plan ahead of whatever you want to create. And on the top is a model of our robot from one of our previous years. So you can also use it to create 3D models of something that you want to build. It's really useful so you can model out the space ahead of time. So you don't end up having any like tight spaces. You can make sure that everything will work out properly. So what are some applications of CAD? CAD is oftenly used in a commercial and industrial designs kind of field. As you can see on the right, there are some models of drones, some models of houses. So they can be really useful for stuff like architecture, construction, and as we mentioned earlier, robotics. You can make some really high detail designs where you have all of the measurements all on one design, so you can easily access it. And you can also use CAD to 3D print or use machines to cut those parts out. So you might be wondering how CAD plays into robotics. So as mentioned earlier, you can use it to model and simulate different subsystems, and you can also use it to create your own custom design parts. And to kind of show what modeling and simulating looks like, I'm going to switch screen share. So this is an animation that Shimon made a few years ago, but as you can see, you can model how the different pieces of the robot will work together. You can model, here's the collection system. You can see the gears and the wheels turning as it moves the ring. You can see how everything fits together in a really nice way that you can easily model and use it to prototype ideas. So that is an example of an animation that you can make. As you can see, the model itself is also really detailed. A bunch of the parts we took from the website of the store that we got them. So it's really accurate. And before we start building, we can see how everything works together. Okay, so what about CAD in the real world? So obviously, CAD isn't something that's just for robotics. You can use it in a bunch of real world applications. So the first thing you can do is create really unique designs. And you can also 3D print or CNC cut. So what CNC cut means is basically you use either a laser or like a water jet to cut pieces of metal into really precise shapes so that you can create boards that have specific words on them or specific shapes on them. Or you can use 3D printers. There's a bunch of different types of 3D printers, but the most common one that you might see is one that kind of goes from the top and slowly puts plastic filament onto a board, and it slowly creates your design, whatever that might be. So as you can see on the right, there are three different unique designs that are some things you could think of CADing up and 3D printing. So the one on the top is like a bat signal for your mobile phone. This isn't really something that can facilitate everyday life, but it is something really cool that you can build if something you really want to do is when you turn on your flashlight for your phone, you want to see the bat signal or just any signal. This is something you could design and then 3D print. The one more in the middle is a model of Wall-E. So you can also 3D print kind of small designs, or I guess like household items. You can 3D print some paperweights that are really cool and something that really resonates with you. And it can be pretty helpful to just have some cool things laying around. And then on the bottom right is a pen holder. So it's very specific in the way the design is like a missile launcher. But it's a way to hold all of your pens so that when you need to grab a pen, you can just grab it from there. And then once you've created these models, you can always 3D print them. So if you're wondering what a lot of like creations other people have used or have made before, you can use either GrabCAD or Thingiverse. And these two are websites where a bunch of people will upload their models, 3D models, and also have some pictures of what they were able to print out. So all of these three were taken from Thingiverse, and you can see a bunch of unique ideas. You can also just straight up take their model and just upload it to a 3D printer to print out whatever you want to do. In addition to just using CAD in like kind of a recreational way, you can also use CAD in a more business way. So as mentioned earlier, a lot of architects might use CAD to model something out. You can also find things like internships at research companies. More specifically, usually it would be with like robotics research. And a way you can easily find those, one is Google. You could also try stuff like LinkedIn. But something I found that was really like easy that you can use to reach out to people and get more experience in CAD are emailing professors. So it can be any professor. You can just go onto a university website and just search up like mechanical engineering or robotics professors, and then reach out to them, see if they have the bandwidth or would be willing to take you as like an intern. And this is also, it's not just for like college students. You can also reach out as a high schooler. I think they're probably not going to accept middle schoolers, but it is a really cool way to expand your CAD skills. Also places like the airport system, Boeing, all of those places will use CAD to model, whether it's like floor plans or the airplanes themselves. All of those will use CAD. If you are interested in playing around with CAD, the software like platform that I generally use is Fusion 360. And we can send out some resources in the chat for you to take a look at as well. So another thing our robotics team is doing is we are hosting a CAD camp, so you can learn some more information about CAD. We'll go over the basics and teach you how to use Autodesk Fusion 360. We'll go over the 2D geometry and 3D geometry, show how you can turn 2D sketches into 3D designs, show you how to animate designs and the concepts of 3D printing. So here's a screenshot of the flyer, and then we can also come back to this later. It is being hosted next week, Labor Day weekend, so September 3rd to September 5th.
So this next portion is going to be a bit of an intro about what FIRST is as a program. So as we previously mentioned, we are FTC team, and FTC falls under one of the programs of FIRST. And FIRST stands for Inspiration Recognition of Science and Technology. And FIRST has many other STEM programs aside from FTC, including FLL Junior, which stands for First LEGO League Junior, FLL, which is First Lego League, FTC, which is First Technology Challenge, and then FRC, which is First Robotics Competition. And FIRST is a nonprofit organization aimed to inspire young people to be science and technology leaders. And FIRST programs engage students in mentor-based programs that develop STEM skills as well as many others. And FIRST hopes to inspire innovation and foster well-rounded life capabilities such as communication and leadership. So some of FIRST's impact is about STEM awareness, skills, and intent, innovation and entrepreneurship, and 21st century work-life skills. So one of the programs that FIRST has is FIRST Lego League, which is for ages 4 through 16, and each team can have up to 10 members. And each team is challenged to design, build, and program and operate robots. And not everything is about competition, but it's also about learning. And some of the core values are gracious professionalism, cooperation, and kids doing the work. And for more info, you can visit the link. And then another program that we, like our team is First Tech Challenge, and it is for grades 7 through 12, and you can have up to 15 team members. And teams are challenged to design, build, program, and operate robots in an alliance format. And similar to First Lego League, it's not all about competition, but it's also about learning, and then the core values are the same. And then for more information, you can visit the site. And so FIRST can teach lots of personal growth, and students will not only develop technical skills, they can also gain many important life assets. And then FIRST also helps build leadership skills amongst the students and lots of social skills as well, including working as a team and with other teams, and then also communication skills, and students can become more independent.
Okay, so in the next section, we're going to go over what a typical season for a FIRST team would look like, specifically an FLL team or an FTC team. Okay, so to create an FLL team, the bare bones requirements you need are 2 adult coaches. So the adult coaches don't need to be professionals in robotics or any other field, but they should be committed to helping the team and spending time with the team to make sure everyone's learning. So for the team members, you'd need 3 to 10 team members that would all have to be ages 4 through 16, but teams can be of mixed ages and genders, so anyone can be in any team. The teams don't also have to be under one organization like a school, so even a group of friends can form an FLL team to just have some fun. So for an FTC team, the coaching requirements are the same with 2 adult coaches that just need to be committed. But for the team members, you can have 2 to 15 team members that are all in the grades 7 through 12. So this program is a little older with some bigger robots. And just like FLL, the team members can be any gender or age, and they don't have to be formed under an organization. So for both FTC and FLL, the major season runs from September to April. And in April is when the Worlds competition is, where people from around the world compete with the robots. But during the summer, as in May through August, there's also some preseason preparations and registration for teams. Okay, so your typical tournament experience would be very fun. So the focus of a tournament is not so much to win, but a big part of a tournament is to have fun, make new friends, and just do your best. So at each competition, each team is normally going to have a table where they'll display what they did over the season And if you ask some team members, they'd be more than happy to talk about the process they went through to get to the robot design or anything else that's on their table. So the tournament experience, it is competitive, but also fun and focused on learning. All right, so for your typical commitment, so for both FTC and FLL, you'd roughly need to meet 6 hours a week during the typical season, but that's not a set in stone requirement. Teams can meet less or more depending on how they feel and how much they've gotten done so far. But even if the team meets for 6 hours a week, there's also normally about 2 hours extra spent by each team member outside of the meetings, just to, for example, work on CAD models that will be ready for the next meeting or other things like that. So for splitting up the work, this also applies to FLL and FTC. It's often effective to split up work into different sub-teams within a team so that everybody doesn't have to be a specialist in each area, because that would be a lot to ask for of each individual member. For example, on our FTC team, we have a software team, a hardware team, and an outreach team. And each of those teams specializes in what they do. So those teams do collaborate somewhat, but there are some people that just stick to what they do best, for example, hardware. And then a great way to organize splitting the work you need to split up is with lists of tasks. And this is what we do as a team, and also a great way to organize any team. So for the robot game, this slide is mostly for FTC. The picture on the left is from an older season a couple years ago, but the information on the right still applies. So there's an autonomous period at the beginning of each match where the robot does something on its own from pre-programmed instructions. So this is the software heavy part of the match, where a lot of the software that was written during the season comes into play. Then the next section is the teleop, which is 90 seconds, and the drivers control the robot. We use PS1 controllers, which work great, but I think any controllers would also do. And then during the end game, 30 seconds, it's just like teleop, but some extra challenges are introduced. Okay, so here's a video from a couple years ago of our autonomous. So for each season, there are multiple cases where the robot would start out depending on who you're in an alliance with and which side you're on. So this is just one case. So here's another case. Yes, that's the autonomous part. This is a sample of what an autonomous section for a season might look like. And then here's a sample of our depositing system for that same year. So this is an example of what we were able to design in CAD and then build. So during this season, we designed most of our robot in CAD. And as you can see, that allowed us to make all these tight fitting components that all work really well with each other to do this specific task.
Sorry, I think my Zoom like glitched or something.
Yeah, you're good. Okay, so now here are some technical resources that you may need in the future if you are going to do FLL or FTC. So these are a bunch of software resources. We have most of these I think are for FTC because the software is a lot harder, but I'm not really going to go into detail here on all these resources now. I think we're going to send this presentation out to you so you guys can review those on your own because there's a lot more to dive into than I can talk about here. And the same for hardware resources. Yeah. So now, do you guys have any questions for us about anything we presented or just anything related to robotics and FIRST and CAD? Feel free to turn on your mics or just post something in the chat.
Yeah, one other thing, the reason why a lot of times for like hackathons, we don't say like it has to be something programmed is because you can always CAD something that you use for your project. For example, I know for example, if the theme is something like natural disasters, you can kind of design your own gadget that can help with, it can either be like designing something that can help like, I guess natural disasters might not be the best example, but if you wanted, let's say the topic is health, you can kind of CAD something up that's related to health. It can be something really simple that's like, I guess, a new type of wheelchair design, something like that. So you can use CAD in your hackathon like project. It doesn't just have to be something that you program since it does still show your technical expertise. And then in the chat, I also sent out 2 links. The first one is if you're interested in downloading Fusion 360, the website is the first one. And then for some additional information about getting like the free trial, so you don't have to pay for it, is the second link on our Google Docs. And then also here is the flyer for our CAD camp.
If you want, you guys can screenshot it for later.
Yep. But yeah, as Shimon mentioned earlier, this is basically all of the content that we wanted to go over. If you're interested, we can also do some screen sharing for some of the Fusion 360 projects that we were able to make. Or if you have any questions about FIRST, FTC, or CAD, you can just leave them in the chat. or you can unmute your mics. Okay. If there aren't any questions, Shimon can share his screen with a few of the things that we've worked on for Fusion, so you can kind of get an idea of what that looks like.
It might take a couple minutes to load up, but yeah.
Oh, did someone raise their hand?
I raised my hand, and
Okay.
I used Fusion 360 before. I once used it for a school project.
Ooh, that's cool. What was your project about?
Basically making some sort of a machine that I saw from a construction site, like a crane or like some flower or something.
Ooh, yeah, that's really cool. Yeah, so Fusion and CADing in general is pretty useful. I guess like cranes and stuff, it's especially useful for stuff like that because some of this like smallest adjustments and lengths or dimensions can just completely change how effective your design actually is. Okay, Shimon, do you have Fusion pulled up or?
Almost.
Okay, yeah, Fusion, since it does have like a lot of parts in it and stuff, since it has a lot of parts and stuff, and the actual animations and rendering, which basically makes it more realistic, can be pretty large. And yeah, we can send this PowerPoint to you all. Let me get the link. Oh, and then here is our contact information in case if you have any questions, feel free to reach out to us. Okay, so yeah, I just sent the slides in the chat. And then I also typed out our email.
Okay, I got Fusion open. Nathan, can you stop sharing? Yeah. All right, so here is a part of our robot from last year. This is the collection mechanism. And so as you can see, a lot of these parts are actually imported from the website that makes the parts that we use. For example, these wheels we imported, as well as these axles and this motor. We didn't make those ourselves because there are a lot of online resources for already complete models. But the rest of the stuff, for example, all these side plates and this part that we 3D printed, we all designed and made that ourselves using 3D printing and a CNC machine. And then that also fits into the bigger picture of our robot last year, as you can see here in this like mock render view. And so this also contains a lot of the other stuff we designed. For example, this mechanism right here that can lift and lower this blue thing. Sorry, it's a little laggy because it has to render everything. But we also designed this chassis down here, which these parts are all components that we didn't cut out or print ourselves, but this did help us fit everything together so it would have a nice functioning robot. Yeah, so I can also see if I can pull up some stuff, some other stuff. So this is a smaller component that we 3D printed yeah, I think a couple years ago. And so this mounted onto linear slides to help us attach those to our robot. So the stuff you design doesn't have to be big. This is like maybe 1 inch by 1 inch component, but this is pretty cool too. Okay, Nathan, do you have anything else you wanted to say?
Yeah, so the good thing about Fusion 360 is it doesn't really have any like coding. So what you can do is you can create like untitled documents. And it's a little bit more like drawing in a way, rather than you have to code anything. I guess, Shimon, do you want to try opening a new one?
Yeah,
I'm not sure. Okay, so yeah. But as you can see, what you can do is create sketches, which you can use to draw stuff out, which you then use to model. The controls are pretty straightforward. It's just you click and drag, or sometimes you just click multiple times. Yeah, so you can make a lot of cool designs with Fusion, and a really easy way to learn Fusion is just by using YouTube. There's a lot of great tutorials and beginner exercises on there. And then we also have our CAD camp if you want to get more into specific details. And then there was another question, which is what schools are the teammates from? So I'm from Interlake High School. Shimon, Abigail, do you want to reintroduce yourselves? Because some people might have joined late.
Sure. So I'm also from Interlake High School, but I think Nathan is a senior and I'm a sophomore.
And I'm an 8th grader going to International Community School.
Our other team members, I think a couple of them also go to Taiyi and I think Eastlake or something like that. But our team is really diverse when it comes to who goes to which school.
Yeah. So the thing about robotics teams is, as we mentioned earlier, they don't have to be from the same school. You can just do a more like community team, and just get a bunch of friends to create your own team. This is a little bit different for FRC, since FRC is a lot larger. The robots are a lot the size for these robots are 18 by 18 by 18 inches. Sorry, the size for FTC robots are 18 by 18 by 18 by 18 by 18 inches, whereas for FRC they are I'm not sure about the specific sizes, but they're a lot larger. So yeah, because the robots are larger, the costs are also a lot larger. You generally want to do it with a school to help with finances. And then for where do we meet? Meeting usually takes could depend on a bunch of different places. Shimon, do you want to kind of mention the different places that you can meet as a robotics team?
Yeah, sure. So our team, we've met in a couple places, including like we've partnered with a Chinese school that's hosted us and let us sort of build stuff in their space. But then currently we rent out this warehouse area with another team. So it's pretty cheap that way and it's a nice space to use. But some other locations you can use are if you are under an organization like a school, you can use their space, or just renting out an office space works too. So honestly, just any space that you can find.
Yeah. Are there any other questions about either CAD or robotics in general? Oh yeah. There was also a question about, I guess, like where FTC is. So FTC is an international program. So you can, so it's not just like in Washington. There's also some teams in different places, like there's some teams from Japan, Mexico, China. So there's like a lot of, it's not just in the United States. So another great opportunity for robotics is you can meet new people around the world and see the different like designs that they have. As mentioned earlier, it's a great opportunity for you to learn and grow as a person. You can also learn more like about the engineering design process, how to think more creatively, stuff like that. So yeah, robotics is a really great experience. You can grow a lot from it. Are there any other questions? If not, since this was a relatively shorter workshop, I think we can end it early. And then our email is in the chat. So if you do have any questions, feel free to reach out to us. Oh, and then for like prerequisite coding requirements for FIRST in general, you don't need to know any coding languages, but eventually you will need to like be able to use it to create your autonomous period and like actually make your robot controllable. But those are all things that you can learn along the way. There's a lot of resources online that you can use.
Okay. So I guess if we're gonna wrap this up early, I think Nathan, I think you're gonna send out a copy of the presentation, right?
Yep, I'll send out a copy of the presentation, and this is also being recorded, so I'll send that out too.
Okay.
Okay, cool. And then if you're for the hackathon, we do have one last check-in today at 9 p.m. So if you have any other questions, feel free to go there and we will answer them for you.